Hello and welcome to escrobot. Escrobot is a smart contract on the Ethereum blockchain and has the name escrobot.eth. It is a pure virtual robot that provides simple automated escrow service to anyone. In this brief video I will cover three topics. First, I will present a few slides to illustrate what escrobot does. Second, I will demonstrate how to find and install an open source reference user interface that makes it easy for humans to work with escrobot. And third, I will use the GUI in a test environment to show a normal sale. In order to understand escrobot, let's review the typical e-commerce scenario. We have a buyer and a seller separated by some distance. We don't know how they found one another, but we assume a market website such as Craigslist or OpenBazaar or something like that, it doesn't matter which. Our parties have agreed to a sale of an item, perhaps an ice crusher cocktail blending machine. Our buyer will have to pay somehow, and the seller will ship the item using any commercial delivery service that can provide a tracking number. Here we need an intermediary to make the sale possible. A bank or credit card company will hold the buyer's money while fulfillment and delivery complete. Our buyer pays with a card and the card company approves the buyer's credit. The seller then ships the item and obtains a tracking number or some kind of reference, which she then shares with the buyer. Sometime later the item arrives, the seller gets paid and the buyer pays his credit card. Done. Now let's repeat the e-commerce scenario. But we have a choice to make. We could take the blue pill and stay in fiat fantasy, or we could take the red pill and spend crypto, which is strangely a harder system of money than physical money is. Here's escrobot. Escrobot is a smart contract, a small program that exists now on the Ethereum blockchain and is ready for anyone to use it. It's a pure virtual vending machine in the matrix. All it needs is a coin, and it'll do its job. We have our buyer and seller again having made a deal for an item. This time the buyer will pay with Ether, the built-in currency of Ethereum, or with an Ethereum token that complies with the ERC20 standard. The seller starts the process by submitting the order information to the escrobot smart contract. This includes a description, the price, and the currency of the sale, as well as a couple of other parameters we'll describe soon. The seller also pays escrobot a small fee, some number of cents for its trouble. A robot has to make a living too, you know. When the details are submitted, escrobot creates and publishes a unique order ID, which will be needed in order to update this order in the future. The buyer will need it in order to pay, which is the next step. But before we go down the sunny path, let's pretend the buyer has changed his mind, or disappeared for any reason. The seller may choose to cancel her order at any time before payment is made. Better to close the offer than leave it hanging out there. In this scenario, the seller is only out some cents, a loss, but nothing significant. Now instead of canceling, let's say the buyer calls the buy function on the smart contract and provides the necessary payment in Ether or whatever agreed upon token. The payment is actually two payments. The buyer pays the amount the seller will receive at the end, her demand. The buyer also provides a bond that he'll get back at the end. The seller sets the amount of this bond based on her perceived risk. If she knows the buyer or has done business with him before, maybe this bond is, 10%. But if it's a stranger and the sale's a big deal, the bond could be higher. Once the buy function is done, the funds are held in the smart contract, and the next step is up to the seller. But before we go down that happy path, we should consider what happens if the seller bails out and disappears. The buyer's money is still locked in the contract. Now, one of the parameters set by the seller when she submitted the order is a timeout. A number of blocks to elapse to allow her enough time to ship. If this number of blocks elapses since the order was paid and the item still hasn't shipped, then the buyer can call timeout and the smart contract will return his money and end the deal. But let's say the funds are in escrow and the seller notices the payment's been made, and so then she ships, just as before, and receives a tracking reference. Now she provides this reference to the smart contract with the ship function call. If shipment fails, then insurance and the seller's goodwill may result in updated shipment references. The seller can update and ship any number of times. The buyer and seller can also add notes to the order, stored on the blockchain with the order forever, to help resolve any issues during the order or perhaps work out support issues in the future. Now, however, let's say that the shipment arrives in good order. escrobot doesn't pay out until the buyer acknowledges receipt. The buyer wants to do this because he wants his deposit back. So he calls the smart contract, and the contract completes the deal. It passes the seller's demand to the seller and returns the buyer's bond back to the buyer. Deal done. No intermediary needed except a robot. Viewers may recognize that escrobot is simply a state machine that's also able to process payments according to some simple rules. Here's a view of escrobot's DNA called a state chart. The chart shows the 6 possible states that an order can be in at any point in time. Transitions are marked by arrows, and labels indicate who and only who is allowed to move the state. Starting at top left, the seller moves the order into submitted when she submits the order details. From here, there's only 2 possible transitions, either to canceled or to paid. If it goes to canceled, then no further transitions or actions are possible. The robot won't allow it. But if the buyer pays instead, then the order moves to paid. And once in the paid state, if the seller's specified timeout occurs, then the order goes to the timeout state. Money moves when that happens, but that part's not shown in the diagram. But if the seller does ship in time, then the order goes into the shipped state and stays there, possibly being updated any number of times, but still in the same shipped state. And then all this until the buyer finally receives it and confirms. And once it's moved into the confirmed state, then escrobot automatically does the payouts and the whole scenario ends. Done. What are some of the advantages that escrobot offers to e-commerce? Primarily cost per transaction. Escrobot can perform a simple escrow service for a few cents. There's no intermediary pay service required and no overhead. The next cheapest option would be escrow.com at around $26 per deal. That's 100 times more than escrobot. And escrow.com is tied to the credit card agencies. The credit cards are even more expensive. They take a significant percentage and earn billions of dollars in profits annually. Sure, you can go private escrow for high-value items like sports cars and boats, and lawyers provide escrow services for things like property conveyances. The professionals could easily take 10 to 15% and up depending on the circumstances of the sale. After cost, there's decentralization. Nobody owns escrobot. It is its own business and nobody can shut it down. There's no bureaucracy to impose any rules on it. It only has to obey its own logic, which is public, by the way. Anyone can see it. And all this for freedom. Anyone who can connect to the internet and get an Ethereum account has the freedom to do business as long as they can ship. And privacy and freedom are coupled. Can't have one without the other. escrobot stores no personal details. All it knows about buyer and seller is an Ethereum address. It's up to the seller what to place on the blockchain in terms of item description and shipment references. And these could be encrypted or encoded somehow. Anything goes as long as the buyer and seller know the order ID and as long as they follow the sequence. escrobot can work as fast as the parties can make function calls. The shortest possible interaction would be 4 states, and that would require a minute or so in Ethereum, and Ethereum 2.0 could be even faster. escrobot could interact with humans or other smart contracts. It could be integrated with the existing processes for any organization that has an e-commerce capability. It could serve as the back end of decentralized marketplaces that want Ethereum capability without a blockchain or pay provider in the way. And to be fair, here are some disadvantages of escrowbot versus credit cards. Escrowbot cannot offer additional services such as travel and health insurance. Escrowbot can't insure the parties against willful misconduct by the other party. It can't offer deals on car rentals and hotel accommodations, and escrowbot doesn't have a loyalty rewards program. As mentioned, the parties can correspond on the blockchain. If they don't encrypt, then intermediary spies could figure out who's buying what and where it's being shipped. And real life is complicated. Escrowbot is simple. Escrowbot can't just do something to help if real life throws a curve. This simplicity is a form of strength, since a deal can't be altered once the parties are locked in. But escrowbot does lack flexibility that could be convenient in life's real, unforeseen situations. And that concludes part 1, the chalk talk part. In the next part, I will demonstrate how to find the smart contract and how to retrieve the official reference user interface. And now for our second part of the video, I'm going to show how to locate the escrowbot smart contract and how to locate and download and install the user interface. So to get started, I'm going to bring up a web browser and I'm going to point it at the Ethereum blockchain, not the blockchain itself, but a scope on the blockchain. There's different kinds, but Etherscan is one of the better known services. And I'm going to type in escrobot.eth, and the Ethereum address for this is that takes us to the smart contract. You can see the number at the top of the page here. Now here's the source code for the smart contract, is all included, so anybody's welcome to take a look and see how it works. And inside the smart contract there's a couple of public variables, external link and signature. Now we can see what those currently are by going read contract, and there's the external link. So you can see it's a string and it's an IPFS link. So we copy the IPFS, and in case anybody doesn't know, IPFS is Interplanetary File System. You can download any resource by putting that big ugly string that I just copied that starts with a big Q. And you can download it that way and just save file. Or there's another way to do it. I'll put that down. If you happen to have IPFS running, you can just go IPFS get and then specify that big ugly hash, and then it will pull that down. Now I happen to know that's a TGZ file. You could go file, whoops, gzip compressed, there's a clue. So anyway, tar ZTF for table of contracts, content, sorry. And there you go, it gives you a list of all the files in that tarball. So let's go ahead and extract it. There we go. Remove it. Okay. Down into escrowbot. This was just created by the tarball. If we take a look at the files that are included, the ones that matter are package and index. So we're going to run this program using an interpreter called NW. I'll just bring that up. nwjs.io. So what this is a combination of the Chrome web browser and the Node.js JavaScript interpreter put into one binary program. And you can download one for whichever operating system you're on. I'm on Linux, so it It automatically figures out I can download one of these, normal or SDK. Most people can download normal, it'll be just fine. If you're a developer, you might want the SDK. Gives you a couple little extra tools. Now I just happen to have NW already installed, and the way to run it is NW dot. Now what it's going to do, the dot is a current working directory, and it expects the directory indicated by this argument to contain a package file, and that's really just some meta information, but it points to this index.html file. So when you load the program per se, it's going to find the package, read the package file, find the index file, load the index file. In the same directory here, I've got a manual. Might be worth a read. I've got language packs for English under the language subdirectory, included libraries. I've got all the scripts that make up the application itself are in here. Everything that is part of the application is included. Some theme stuff and some test stuff. That's not going to work, but there we go. There's what the UI looks like when it comes up. And in the next part, I'm going to show how to connect this UI part up to Ethereum, and then I'm going to show how to use it to complete a sale. And welcome to the client demo part 3. I'm just going to start up my test environment, test version of Ethereum, with 2 pre-configured accounts in it that we're going to use for buyer and seller. And I'm going to deploy a test version of escrobot. Alrighty. So here's how the UI comes up. Initially, this pick list for eth account is empty because it doesn't know who I am yet. There's a selectable theme which just dynamically changes CSS. And then there's a language pack so that people can dynamically select languages, just the labels. Here in the start screen, the Ethereum gateway needs to be set. It's red because it hasn't connected. I'm on the wrong port. Ganache is on 8545. And then it turns green because it connected. Now I'm going to take the pre-configured private key for 2 accounts and load them. And you can see that the eth account now has a value in it. And it's figured out the balance of that account and the nonce. I'm going to load the other one as a geth file. This is what geth would have if the account was created through the program. Alright, now you can see both of these test accounts are now selectable in here. Now most people will only be using one or a few accounts, but I'm going to switch back and forth for, I'm going to make this the seller and I'm going to make this account the buyer. So if, remembering from the previous parts, the scenario begins with the seller, and the seller submits the description of the deal into the smart contract. So as seller, I'm going to fill this out. And we're going to make the deal for, I don't know, 0.2 Ether. you can select different currencies. You can use Ether or you can use any ERC20 coin, and I'm going to show how to load a different coin in a minute here, but for now let's just say 0.2 Ether, and this is the bond, the buyer's bond that the buyer has to put up in order to provide some assurance that he's going to confirm at the end of the deal. This can go all the way up to 255 legitimately, and it's an integer, but it can't go beyond. So we'll just leave it at 25. And we're going to ship within 10 blocks because this is a test environment. Submit. Pop-up comes up confirming what account it's coming from, how much value is being spent, how much gas, all this kind of stuff. And there's the blockchain transaction reference. Now this scenario shows the answers and everything coming back really quickly, but in real life it's going to take a while for these transactions to be mined. So you can see now I've got an order. This pick list. Whenever this tab refreshes itself, this pick list always figures out what orders are open for this user. So this user is seller just created this order, and you can see it's pulled all these values back, and none of them are changeable at this point. So at this point, the seller could cancel at this point because the buyer hasn't come along and paid yet. So let's take this order ID and come along as buyer. Now the buyer account, which is going to be this one, the buyer doesn't have any orders yet. So he can take this value that's been provided by the seller for order ID. And you can see it's gone and fetched the the values that the seller put in from the Ethereum blockchain. And the only button that's available is to pay. So you can see the order's been broken down into exactly how much I'm going to pay, and this is how much I have, 100 ETH, so no problem. I'm buying with Ether, this much. Alright, so now the item was paid for in block number 6 on the blockchain, and the seller has 10 blocks in order to ship. So if I tried to claim a timeout now, even though the button's here, it would fail. The smart contract would reject it. So now it's sitting there in the paid state. Let's go back as seller, and we're going to load this because it's still not closed. You can see it says, oh, it's been paid. And the seller says shipment reference. So, I don't know, UPS, some sort of shipping reference. And there, it's in the shipped state. And so then as buyer, once the thing shows up, I can confirm it's delivered. Payment happens. This goes away because I don't have any open orders anymore. And it goes away for the seller as well. Fortunately, it automatically puts this order ID in to this field, and whenever an order ID is put in there, it fetches the events from the Ethereum blockchain, from the smart contract event logs pertaining to this order. So you get a date, time stamp, whoops, the state, and the sender. So it just shows who submitted, who paid, who shipped, who completed, and what times roughly those happened. And you can see if you're the buyer or the seller, then this button down here to add a note. So even after the sale is done, you can add a note to the order. So arrived in good order. And again, that's a few cents. and the event went into the blockchain, and now it's come back. And again, I'm showing this happening really quickly, but in reality, each of these transactions is going to take a minute to get mined. Coming over the settings tab, just to mention, because I'm using this test program here, it automatically sets the gas price to 20 gigaway. In reality, that's about 10 times at least more than normal. This will automatically update, and if you override it, that override will stay with you throughout the life of the program. Again, nothing is saved on disk, so you'd have to set it next time you run. And here, if you like, there's a link to the proper eth gas station website, so you can see what the actual current conditions are. And here's this is the test SCA, escrobot SCA. And if you click on it, it's a link to Etherscan, and it'll try to bring up that contract, which doesn't exist on mainnet, of course, right now, because this is test environment. And it lists the escrobot fee, which in this case is 2,000 Jabo, and a Jabo is a millionth of an Ethereum, so this is really only about 40 cents, I think. And just want to demonstrate how to add a token. So I just happen to create this token for the test environment, and it's just a dummy token. But if you stick a token SCA in here, it'll attempt to find the details from the blockchain, and then over here in the seller tab, you can sell something for that token. You can make that a currency. So with this program, you can buy and sell anything that you can ship, and anything that you can pay for with Ethereum or any ERC20 token. So maybe as this guy, maybe sell something else here. One Monero, and let's say we're going to set the price in ABCD. Let's say that's 100 ABCD or something like that. So we could make this deal now, and this ABCD token will be a requirement, and the escrobot smart contract will enforce payment with that token. And then when it came to shipping, this could be a transaction ID or a view key. So you could do currency swaps with this kind of thing. So this is a very generic, simple escrow agreement. And then there's just some license and that kind of stuff, information back here. And that is the demo. Be sure to read the manual. The manual has all this stuff in it. And take a look at the source code and make sure that it doesn't have any hacks in it, and that you got it from the right place, and that nobody else has had a chance to put anything in the way, and use in good health. Thanks for listening.